All right, cool. I think we can get started here. So welcome back, everyone. This is the third and final installment of the Quadrotor workshop hosted by McGill aCADemy. This particular section is going to be quite a bit shorter than the other ones. We're just going to be essentially working around the geometry that we created last time in our arms and essentially creating the propeller of our quadrotor this time. The hardest part is just going to be the blades of the fan itself, but I can assure you that it's not going to be that difficult. And I'll show you how to approach it, essentially. Essentially, what we want to be able to do is develop the skills necessary to see a problem such as this one, where you have some complex geometry and say, hey, I can boil this down into multiple steps. So without further ado, I'll just share my screen here. So just give me a moment. Cool. So this is the final product of what we want to create today. And for this tutorial, considering how short it's going to be, I'm just going to roll back our changes and we can approach this one by one as well, because I want to be able to show you guys what I immediately thought when, I see an image of a propeller online, or if I was provided a drawing, how I'd go about CADing this. So firstly, and I'd say probably the most important question is, how the hell do we CAD these blades? You have geometry that is very thin on one portion and, is very curvy, but on the other end, it's significantly thicker. And, I did this without any dimensions, but usually say if you're given a drawing, you'd have to abide by those dimensions somehow, right? Well, firstly, to get to that, we need to create our base, right? So I'm going to roll back our changes by moving this little bar up here. And we'll go up to the first extrusion that we made, which is essentially the base of our CAD. So when I go into edit feature, and I right clicked on that component and I'm going to be editing, we can see that I extruded by 4 inches prior to this. As well, if we take a look at the actual sketch itself that I made this off of, if you're not familiar with sketching, maybe refer back to our previous videos. But this is a 2-inch diameter. Remember that I am currently working with IPS units. So essentially, we're going to be creating a cylinder with a 2-inch diameter and a 4-inch length for our base. Cool. Now, I also did this all on, the top plane right here. But you can choose any plane you want. It's up to you. Give me one moment. Cool. And sorry about that disturbance. Now from there, what we can do is we can check the next step. So I'm going to keep this bar here for now, and I'm going to rotate just so you guys can see what the change is going to look like. So we have our cylinder here. If we take it down to the revolve, essentially this is going to provide us with the cone of our fuselage, essentially, or the base of our engine or propeller in this case. And creating this was a little bit more complicated than other shapes. So if I go and right click and press edit sketch, now I'll actually go in and show you guys what I did. So what I did is this. So essentially I have an arc, and from there, knowing the center of our cylinder, we're essentially able to create this shape here. So essentially what you can do is take a line, and just give me a moment, sorry about that. And you can draw 2 different lines, one leading up to the center of the cylinder, one going up however much you want it to. I gave this sketch arbitrary dimensions. I just went with whatever looked the most aesthetically, realistic to me. But in reality, you can change that using the Smart Dimension tool. And you got to also make use of relations as well if you want this to be properly constrained. So essentially this point here, the beginning point of our sketch, is constrained to the edge of our cylinder, or at least the projection of the edge onto our current plane. And then this point right here is constrained to the center of the cylinder, right? And then from there, the arc is probably the hardest part. You just go. There's different arcing tools if you'd like. I personally like to always go with a 3-point arc. So essentially, if I click on it and click on one vertex, we click on our other vertex, you see I can make an arc with the exact same magnitude. So it seems that I gave it an interior radius of 60 degrees. sorry. I gave it an angle of 60 degrees and our radius was 2 inches approximately. So you can see the center of our arc is actually constrained to the other edge of our cylinder. And by the center of our arc, I'm talking about that little plus sign that's moving towards the right of the screen. You'll notice I constrained it such that it is coincident with the right edge of our cylinder. Cool. I'm not going to change this geometry because if you say create some new lines and trim a few of the existing lines that you already made an extrusion out of or a revolve, SolidWorks is not going to know what to do and you're going to have to redefine that revolve. But essentially from there, what we could do is we could press exit out of our sketch, and to actually create the revolve, we can right click on the revolve tool, press edit feature. Now, usually you'd make your sketch and then you'd click revolve boss/base, which is a tool in the features tree or features tab up here. But I've already made this before. So for the axis of revolution, which is essentially the line that we're going to be rotating this entire object about, or this new revolve about, I took it as a center line. And that's exactly why I only CAD'd half of our cone here, or at least half of the projection of our cone. And I just gave it a 360-degree revolution. So around that line, we do one entire revolution and then come back to our initial point, which is where the sketch starts from. And I also merged it, meaning the base that we have underneath, these two are going to be part of the same body. Now, what you could also do is press do not merge or unclick the merge button, and there'll be two separate bodies, but I do not want that. Okay, cool. So I'm just going to exit out of that, and then we can move on to the next feature here. So next, I just defined a new plane, right? Because we need somewhere to actually start our propellers off of, right? Now, for the actual plane, I set it as being way up here, right? And then from there, we implemented an extrusion. Now, what you can see is I didn't do this very systematically. Essentially, it would have been wiser to maybe CAD the wings first and then create the fuselage, because if you look as I go up and up, oh, sorry, I realized I actually broke something in my sketch. I think this length is a lot shorter than it needs to be. Give me one quick moment. I'm going to fix that. I don't know what changed. Yes, this should be 4 inches. I don't know how that changed, but we'll press OK. Ah, perfect. There we go. Whew, crisis averted. Because I was like, I looked at the plan and I'm like, why isn't it at the point that I need it to be? But essentially, the point of this new plane that I created here is such that we have a basis for our propellers. I don't want it quite, sticking to this little ridge that we created between these two objects. I want it to be a bit offset from there. And then from there, I went and extruded an arbitrary shape using this plane. So you can see that I did this. And this actually brings up the one strategy that I wanted to talk about that I think is super important whenever you're CADing some sort of complex geometry. So if we go and undo all of the step backs that I just implemented and we go back to the actual assembly, we'll notice that we have these two different wings or blades essentially. And the way that I like to approach problems like this is I think, okay, how do we deal with this in terms of projections, right? So this is a complicated shape to try to do all with like either one sketch or a set of splines. You're going to waste a lot of time essentially on defining a bunch of arbitrary points that you're not sure is even going to yield the right result. So what I like to do is I think, okay, say if we look at it from the z-axis, for instance, is there any sort of shape that we are projected? Or is there any sort of, I should rephrase that a bit better. Is there any particular shape that is outlined that is easy to sketch? So in this case, we'd have to go and sketch all the way across this top portion, and then we have to go here, we have to come down, so on and so forth. This one's not so pleasant in my idea. Now, what if we go and look at the x-axis, for instance? Well, you'll notice this shape is actually very, very easy to CAD. or very, very easy to sketch, I should say. So what we have here is one proper profile, two different arcs with different radii, and one straight line connecting the two. So what we can do is we could say, okay, for the first stage, we're going to take this sketch and we're going to extrude it out towards us along the x-axis, right? And that's exactly what I've done here. So if I roll back my changes and go back to the first boss extrude, you'll notice the shape is the exact same, but the only difference is I kept this base geometry. So what I did is I did a straight extrusion from that sketch. And to make that sketch, what I did is I said, okay, we'll press edit sketch. And then having this edit sketch selected, what I did is I CAD'd this using the right plane right here. So it's on the right plane. And you'll notice it's actually going along the center of our propeller here. And it's underdefined mostly because I just didn't have a set list of dimensions that I went off of. I just sort of eyeballed it. But I just made two different arcs, two different arbitrary arcs. And I also accommodated for where our current, our plane was as well. So I used that as a basis for my CAD. But essentially, I put a straight line between these two different arcs. And then from there, I went and I clicked on the extrusion tool. So essentially, this will allow us to go and extrude right from the middle of our object, like so. And let's see. That should likely be merged if I am remembering correctly. Yes, exactly. I merged it. Cool. And then we're good to go. And then we'll go on to cut extrude. So this is the second step that I was talking about. So we essentially went and said, okay, this block that we created in this first extrusion is not adequate. That is not what a blade is supposed to look like. We have to cut some of the meat off of it. So let's refer back to our previous state, or the initial state that I showed this CAD, which is its completed state. So what I did is I said, okay, we have this X projection done, perfect. Now, the next step is seeing, okay, where could we cut this from next? Well, if we do a Y projection, or if we look along the Y axis, you'll notice this shape isn't terribly difficult to, sort of create a free flowing shape of either, right? It's just one big arc, and you can essentially implement a couple of tangency constraints to create this nice free flowing body. And from there, that big square piece that we had before, so if I roll back to our first projection, this big rectangle that we originally had, what you can do is you can actually cut this shape out of that, right? And the product of that is actually pretty cool. What you get is, and if we go back into here, into our cuts, you'll see that from the top, this shape looks perfectly normal. It's just one set of free-flowing members. But if we rotate the camera, you'll notice because of our first projection, or our first extrusion, which was along the x-axis, we have varying thicknesses like real blades do. And you could even refine this further. You can go and say, okay, I don't really like this rear portion. It's maybe too bulky. It's up to you. I'm essentially just here showing the basics. So what I'm going to do is I'm going to edit the sketch just so you guys can see how I actually made this part of the CAD. But essentially, you can see I have the following. So we initially had the outer edge of our, our first extrusion. And the way that I essentially projected this onto our current sketch is I used the convert entities tool, right? So what you can do is you can essentially go, and it's a bit difficult to see because we have the extrusion in the way, but this is the original shape that we had before this step. And I went and I clicked on all of these linked edges that you see here. I clicked on all those edges with the convert entities tool. And then, so if I do that like so, you'll notice that at the end of it, and if I exit, you'll notice that at the end of it, we get this rough rectangular outline that we got from the first step. So essentially, convert entities is a way of projecting curves from another plane onto your plane. Now, in this case, the two planes are parallel, so it's going to be a one-to-one projection. But if it's oblique, keep in mind that it may not be the same dimensions. It definitely won't be. So from there, given this outer edge, I said, okay, these are essentially our constraints. So then from there, it's just a matter of having fun with the CAD. I just went and I created a bunch of different arcs. I said, okay, this one is going to go here. It's going to end up, approximately, we could say over here, and it needs to be touching this rectangular portion. So if I shift click, so I click on this first arc here, and I shift click on this top edge here, and you give it a moment, you'll notice I can add a tangency relation to it. And I can actually move this endpoint about as well. I can move it around, and you'll see that's actually how I got this first top shape too. And essentially what I did is I just connected a bunch of different arcs to it. So I connected them together. Say if I want to do another one here, say if we got tired of this guy and said, okay, I want one arc that goes all the way down here, and we have this following shape. Well, you'll see it's a bit rough about this vertex here. So the way you can actually get rid of that roughness is clicking on one arc, shift clicking on the other arc, and then applying another tangency constraint. And now you'll see it's a lot smoother, and you can essentially play around with it for yourself. I'd recommend trying to, either recreate this shape or something a bit more unique. And from there, you just create a closed contour such that you essentially have an outline. So I'm going to get rid of these shapes that I just created because they're going to mess up our extrusion. So we can get rid of that. And I'm just pressing undo here. Cool. And essentially from there, we have to say, okay, we have this outline now. What do we do with it? Well, obviously, we want to preserve this interior shape, right? And the reason why I projected the outline itself is because I'm going to go and select each of these individual contours that are outside of this blade as our cutting tool, or for our cut extrude, they're going to be the contours that we select. And that's exactly what I've done. So if we exit and press, I'm going to right click and show you guys what I did for the actual cut itself. Give it a moment. Cool. You'll see there's a couple of different contours that I selected, right? I'm going to deselect all of these just so you guys can see what I actually did. So clear selections, and then we're going to clear the feature scope. And actually, I'm going to keep it as it was, sorry, because I realize it's actually going to go and affect our geometry later on. Edit feature. Sorry about this. My computer's a little slow. Cool. And I'm just going to get rid of these contours again, and we'll do it again right from scratch. So right click, clear selection. Cool. So I'm going to go and click on this first contour here. It's actually a bit difficult to see because you can't see the highlights, but you can see it selected this first interior contour. We're going to click this one as well. We're going to click the one on the outer edge, and then we're going to click this final one too. And then from there, I just did a through all cut, meaning that given this sketch plane, I'm essentially going to cut every sort of material in its way. So we're projecting upwards along the y-axis. And from there, any sort of material that this tool intersects with is going to be removed, at least within these contours. And if we press OK, this is what we get consequently. Our perfectly cut part. And this interior portion is preserved. The other thing you could do is you could say, okay, I could select this interior contour here, and then you could click flip side to cut, which is another option. I personally don't find it as intuitive, but I mean, it's a shortcut. There you go. Cool. And then from there, what I did is I created this axis just about here. That's more just as a piece of reference for myself. because it can be a little bit difficult to actually select this cones axis. And then from there, what I did is I split this propeller from the rest of the body. The reason for that is mostly just so I could color it a different color. But in real life, if you have two different components that are, say, welded together, it would be wise to deselect the merge results checkbox that we usually have in our extrusions. So that's a general piece of advice I'd give. And now the final step is, okay, we have this particular propeller here, or this particular blade here. How do we go and recreate this without mirroring? Because if you can imagine, say if I were to look along the y-axis, if we were to mirror this shape about this sort of I should say the x-plane, the plane where that is coincident along the z-axis, you'll notice that you would essentially get two different arches. So one, if you're following my mouse here, you essentially get the exact same shape, just flipped along the z-axis. So it'd look exactly identical, and this wouldn't actually be able to fly. So what you have to do is you have to implement a circular pattern instead. So essentially using that axis that I defined in the step earlier, what you can do is you can essentially go and using the circular pattern, rotate it 180 degrees about that axis. So if I right click on circular pattern here and click edit feature and give it a moment, you'll see that for the direction of this circular pattern, I selected this axis that I created in the previous step. And I said, okay, I want to have one more propeller, or I want to have one more blade. And I want this blade to be 180 degrees apart from the previous one. So I assigned it an angle of 180 degrees, and I also gave it two instances. The first instance being the original one. And if you exit out of that, you'll get the flip shape that we desire. And then, as you can see, I went and just split this other one as well. Perfect. Now this final split that I created right here was actually created using that first plane that we made in the first step, because obviously for this to actually work, it can't just be one composite part. It needs to be a motor connected either axially or with some other type of fastener method to the top of the propeller, which then rotates the blade. So essentially, this component and this component cannot be essentially welded together. This component on top needs to be able to spin about this fixed component right here, which is supposed to simulate our motor, right? So that's that. And I'll come back with the full assembly just to show you guys what I've done. Awesome, and we're back. So what I've done is I've fully loaded the assembly, and I've actually gone and duplicated each of these propellers. And all I did was just constrain them concentrically to the inner parts of or the inner, here, I'll actually show you guys what I mean. So we'll hide this propeller, but essentially I concentrically mated the propeller to the inner wall of this arm. And from there, to actually define how high the propeller needs to be, you could also apply a distance mate. So by that, I mean just going to the mate tab, and if you give it a moment, computer's being slow, awesome. You could click on this button right here, distance, and say, okay, from the bottom of this propeller to the bottom of this arm, how far apart do those need to be, right? But I've already defined this, so if I define a new one, it's going to over-define the assembly. But now you can see in terms of our assembly, we have the full degrees of freedom that we desire. Now, realistically, you'd need probably a better way of fastening these motors, but I just wanted to CAD up something quick just to show you guys the different tools that play here. But yeah, that essentially concludes the drone Quadrotor workshop that we were hosting for the past few weeks. If you have any questions, just feel free to let me know, but this was by no means meant to be some sort of rigorous way of showing like a fully fleshed out design. Essentially, this is sort of an approximation of what your design could potentially look like. And then from there, if you desire to improve it further, that's totally up to you. Maybe iterate, make the arms a bit thinner, develop better fastening methods. Essentially, the sky's the limit. But honestly, thank you so much for your support. It's much appreciated. We also appreciate all of your feedback regarding our previous workshops. So if you have any questions, feel free to let us know either by emailing us or by joining our Discord help desk. And yeah, it's been a pleasure teaching you guys. Awesome. Well, thank you very much and have a good evening.